Hi, folks. Good afternoon. My name is Ann Stout. I'm a Conservation Outreach Specialist with the Iowa Learning Farms. Sitting in today as your webinar host in place of Dr. Matt Helmers. I'm excited to be here today and more excited to welcome our guest presenter. So for today's webinar, we will be welcoming Dr. Rashelle Matthiesen. She's with Iowa State University's Department of Plant Pathology, Entomology, and Microbiology. So her research is focused on addressing Pythium species that can infect corn and soybean crops, causing seedling disease. And her recent work is addressing cover crops, particularly cover crops ahead of corn, how that impacts growth and development, seedling disease, and crop yield. So we're going to be hearing about a subset of that today as Dr. Matthiesen dives in with her presentation, What Lies Beneath: Impact of a Cereal Rye Cover Crop on Corn Seedling Disease Severity. So just a quick primer on the format of the webinar. Many of you are regulars on our series. So Dr. Matthiesen will give about a 25-minute presentation. As she's going, you are welcome to submit any questions in the chat. I'll then convey those to her when we finish the presentation, but please, you're welcome to submit questions as we go, and we'll have that Q&A time at the end. So with that, Dr. Matthiesen, the floor is all yours.
Okay, thanks, Anne, for the introduction. And I'd like to thank Iowa Learning Farms for the invite today to talk to all of you. Yes, I'm going to be covering cereal rye cover crop and corn seedling disease. As Anne said, I'm a research scientist, and I work in Dr. Allison Robertson's lab at Iowa State. And I bring that up because for some reason, my slide is not going forward now, of course. Oh no, it's not progressing. What is going on? There it goes. Okay, great. So, Dr. Robertson and Dr. Tom Casper several years ago got together and were talking about what could impact corn yields, specifically yield drag, when there was a cereal rye cover crop planted in the fall. And they were talking about that this can be seen at some sites in some years, but not all the time. So the question arose then, why when planting corn after cereal rye, are yields sometimes reduced? So I look at this as there's many puzzle pieces that make up the puzzle of yield drag. And so one of those puzzle pieces is planting issues. So you can have uneven stand when you're planting your corn into the cereal rye. You can have low soil temperature from that rye, keeping the temperatures lower. So you have slow emergence of the corn. You also have allelochemicals that could be coming off of that cereal rye and slowing the germination of the corn. You can have nitrogen immobilization from the cereal rye immobilizing that nitrogen, so therefore the corn has low vigor. So there's all these pieces to the yield drag puzzle. And Allison and Tom were talking about the fact that, there could be another piece to the puzzle, which is corn seedling disease. And corn seedling disease can cause a couple of different things that can happen to the corn stand. So you can have uneven stands, you can have slow emergence, you can have yellow or wilted seedlings, you can have stunted plants, and those stunted plants can cause to have no ears produced or smaller ears, which then can impact yield. So we do know that cereal rye is a host for some of the pathogens or the pathogens that cause seedling disease of corn, such as Fusarium species and Pythium species. And so I'm just going to briefly go over the green bridge, so some of you might know what that is. But what we're looking at is when you terminate your cover crop, then when you plant corn, soon after that cereal rye termination, Allison likes to mention that you're planting into a petri dish of pathogens. And then what can happen is you get seedling disease. So you're creating a bridge between the roots of the rye and the roots of the corn, and you can have or increase your risk of seedling disease. So what happens then if you plant corn later and you wait for the populations of the pathogens to go back to levels? Then what happens is, you have less of a risk of seedling disease because that green bridge is broken. It's not formed. And that's good. So a couple of years ago, Allison and Tom and Jatsna Karya, who was in our lab, started working on this and looking into this of planting corn following a cereal rye cover crop. And so what they did is they had different treatments where they terminated the cover crop at different times before and after planting. So anywhere from 1 to 2 days after planting, all the way to up to 25 days before planting. And what Giazza found was that for these 3 different treatments, there was reduced emergence, growth, and yield of corn, and also increased seedling disease, which was mainly caused by Pythium species rather than Fusarium species. And so that came about then for the recommendation of waiting 10 days or more between when you're spraying your cover crop to terminate it and when you're planting the corn. But life happens, or the weather happens, right? And so we can have cold, wet springs here in Iowa, and that can prevent farmers from getting into the field to terminate their cover crop or to plant their crop or plant their corn. And then glyphosate might not be as effective when the temperatures are cooler or ineffective. And so then what do you do? Do you wait and spray and plant later? Do you plant corn and then wait to spray a few days later? And that is called planting green. So Tom and Allison Jatsna then a couple of years ago decided to do another experiment looking at corn disease or corn seedling disease and planting green. And so they had these treatments where they went from anywhere of 14 days before planting to 12 days after planting. And what Giazza found was that for the 6 and 12 days after planting treatments, when the cover crop was terminated, the corn was taller at V3 when the plants were sampled, mainly because the corn was, competing with the cereal rye and etylating. There was also more severe seedling disease and then greater populations of Pythium in that clade B, which in that clade we find a couple species that really like to infect corn. She also found that the highest yield was in the no cover crop treatments, and the lowest yield was in that treatment when the cover crop was sprayed 12 days after planting. And then there were similar yields between the other 3 treatments. So it's still, we keep at the time between when you spray your cover crop to terminate it and when you're planting corn, something like planting brown. So again, though, the question is still there about does planting green increase seedling disease? Not just in Iowa, we've kind of shown that, but across the US. So that leads me to the experiment that I'm going to be talking about today that is funded by the USDA NEFA and is the Precision Sustainable Agriculture project. And if you would like more information, there's a website, precisionsustainableag.org. So Common Experiment 2 is just one experiment in a huge project of this PSA. And so in this Common Experiment 2, we were looking at termination timing of the cereal rye and the effect on slugs, insects, weeds, disease, corn yield, cereal rye biomass. So what I'm going to be talking about today, though, is just the disease and corn yield. So our hypothesis for this project was, again, delaying the cereal rye termination time, and that increases corn seedling disease. So our trial was, we had cereal rye. We used a variety of Elbon in Iowa, and other states used what was more common in their states. So this is across 16 locations. And we planted the cereal rye at 75 to 90 pounds per acre. In Iowa, we usually were around 80 to 90, and so that was on the high side. Everyone planted corn with a fungicide seed treatment, which was Maxim Quattro, and we terminated the cover crop using glyphosate or Roundup. And the plots were 16 rows wide, 30-inch rows by 50 50 feet long. And we did that at the Ag Engineering and Agronomy Farm here close to Ames, so central Iowa. So this is a figure of kind of what our plot looked like, where we took the different sampling, and as you can see, the 2 bars are for disease, the subplots where we did destructive sampling, and we took a lot of data for this trial or this experiment. But for the yield, what we did is we took yield from the 4 center rows where we did not do destructive sampling. So this is a picture of some of the plots in 2021, what they look like after termination. This is a couple weeks after, and what the treatments were for this experiment. We had no cereal rye, we had a planting brown where the cover crop was terminated 2 to 4 weeks before planting. We had a green brown treatment where the cover crop was terminated 3 to 7 days before planting, and then a planting green where termination occurred 0 to 7 days after planting. Now in Iowa, this was for all the states. And for Iowa, what we did is we typically, we terminated at around 3 weeks for the brown, 3 to 4 days for the green brown, and 0 or at planting up to 3 days after for the planting green. So for the webinar today, I'm just going to concentrate more on planting brown and planting green and the comparisons between the two, but you'll be able to see all the treatments and what that was in Iowa. Okay, so this is moving on to cereal rye biomass. This is an aerial photo of the field trial that occurred in Florida. We didn't have one for Iowa, but I liked how this looked to give you an idea of what the different treatments were and when they were terminated. And so when we collected biomass, we collected at termination. We did 4 quadrats per plot. The quadrats usually were in the size of a half of a meter squared. And then we had 5 plots per treatment. And we also then took the cereal rye biomass and we dried it for a couple days, and then we weighed it. So specifically in Iowa, as you can see here on the y-axis is the cereal rye biomass in pounds per acre. On the x-axis, we have the year. What we found is that the biomass was significantly lower in the planting brown compared to the planting green, which is not surprising. That is expected. And that trend, carried for the majority of the states. So 14 locations out of the 16, the planting brown had significantly lower biomass accumulation than the planting green. So one thing I wanted to hint on, though, to kind of explain, in Iowa, there was a general trend of reduced biomass accumulation over the 3 years of the study. And so I kind of wanted to look at soil temperature and precipitation in Iowa. We all know that planting the cover crop as early as we can in the fall will provide a good establishment and therefore have a good accumulation of biomass in the spring for when we want to terminate. So there's a lot on this slide, but I want to highlight that the figures on the left are the soil moisture and the figures on the right are for precipitation in Iowa over these 3 years. And so when we planted the cover crop in the fall of 2020 in later September, we can see that the temperatures were mostly above 50 and there was adequate moisture. So yes, things that happen in the spring are also conducive of how much biomass you can get or accumulate. However, in the fall, there was adequate biomass established. So we got a sufficient amount of biomass in the spring. However, for the next year, it was similar, that we were having decent temperatures in the fall. We got planted at the end of September, and there was adequate moisture there. However, this last year, or I should say in 2022, we didn't plant until almost the middle of October. And if anybody can remember, we had cool temperatures that were below 50, and it was dry. And then when we did get some moisture, it was already cold or freezing temperatures. And so I can remember going out to the field trial in 3 weeks, 4 weeks after, so the middle of November. and there was no cereal rye there. Nothing had germinated. And so that's somewhat of an indication of why we got very little biomass accumulation in 2023 in the spring. And so again, we want, later planting of your cereal rye, you can have less biomass accumulate because of those cooler or cold temperatures and the reduced precipitation that can happen in the fall. So another reason to plant as soon as you can your cover crop after you've harvested your cash crop. Moving on to corn seedling disease. So we sampled the corn seedlings at V5, V3 to V5, and this was across all of the states. So in Iowa, we really tried to sample them at V3, and the majority of the years we did, or V4. We collected 10 seedlings per plot, and we took those seedlings back to the lab where we gently washed them, and then we took photos using our phones of those seedlings, and then we uploaded those pictures to a shared Google Drive for the PSA across all 16 locations. And then I went in and I assessed the percentage of root rot severity for each seedling. And so what we found with that was seedling disease in Iowa specifically across the 3 years. So on the y-axis is root rot severity, and on the x-axis is the year. So what we found with that then is that seedling disease was significantly lower or less in the planting brown compared to the planting green for all 3 years, as you can see. But there's also a trend of seedling disease, lower seedling disease each year as you go from 2021 to 2023, which I will hint on or I will mention now. So again, going back to that soil temperature and precipitation across those 3 years in Iowa, we planted the corn in May 4th for the first year. And as you can see, there's some temperatures that are below 50 there, and there's some precipitation. So Pythium species that cause seedling disease in Iowa really like it cool and wet. So that can maybe be a reason why we're seeing more seedling disease in 2021. So in 2022, we planted middle to the end of May, and warmer temperatures, is getting below 50 degrees, and there's adequate moisture. So those corn plants are coming up quickly. And that's the same trend that occurred in 2023 here, where it was even warmer temperatures. It was a little bit dry, but then there was some moisture. So now we have even less seedling disease. And the reason being is when you plant earlier, you can have more seedling disease if you have cooler temperatures and it's wetter, because Pythiums love that. Farmers don't, but Pythium, they love causing seedling disease on younger or pre and post emergence damping off when it's cooler and wetter. But as we had the last 2 years of the project, there was later corn planting, so there was less seedling disease because those plants were able to pop up faster, grow faster, and Pythium is unable to cause infection when the plants are older. So that's why Pythium doesn't like to cause infection when it's warmer, and that's good for farmers. I'm not saying that you go out and you wait to plant your corn. You're going to plant corn as early as you can. This is something to keep in mind, that if you're seeing areas of seedling disease in your field with a cover crop, this could be some of the reason, especially if it's cooler and will stay wetter in the spring. So what happened then across the 16 locations? This is data from the first 2 years. We're getting to the third year. So maybe next year we'll have another webinar for all of the data across the 3 years. But for the 16 locations, what we found is that at 6 of them, including Iowa, there was a significantly lower amount of root rot in the planting brown compared to the planting green. And again, that was across 2 years. So there are some locations where it's one of the 2 years, but when we look at both years, such as with Iowa, it's at 6 locations, there was lower seedling disease in the planting brown compared to the planting green. So moving on to corn yield, which is what I think everybody wants to know about, right? How does this affect yield? So in Iowa, we have yield on the y-axis, bushels per acre, and year on the x-axis. And what we found is that yields were significantly higher in the planting brown compared to the planting green for the first 2 years. And again, this could be indicative of the soil temperature and precipitation that I mentioned before, but for 2023, there was not a significant difference between planting brown and planting green. However, the no cover crop treatment did have the lowest yield, which is a little bit surprising, but it was an interesting year. And then for all of the locations, what we see is that yield was significantly higher in the planting brown compared to the planting green at 7 of the locations across both years. Again, this is the first 2 years of the project, and the third year will be analyzed soon. But as far as we see now, there's 7 locations for both years. And then there were a couple of locations that had a lower yield in the planting brown compared to the planting green. So that was interesting. And also there are several states that there's no difference between the yield, kind of like that was with Iowa this year. Okay, so back to our hypothesis of delaying cereal rye termination causes increases in seedling disease. So just briefly to go back over what we saw for Iowa, there was significantly more seedling disease in the planting green. So the planting brown had less seedling disease than planting green. And the yield was greater in the planting brown versus the planting green in the first 2 years of the study. As was the trend in Iowa. So across the 16 locations, 14 of those, including Iowa, the biomass was greater in the planting green. And so less in the planting brown, which again is not surprising. Seedling disease, 6 locations, including Iowa, where this planting brown had less seedling disease than planting green. And for yield, again, 7 locations, including Iowa, showed that there was higher yield in the planting brown versus the planting green. So what does this mean for the puzzle, right? Like, I think for Iowa, we're moving a little bit closer with that puzzle piece to fit in the yield drag puzzle, to understand that seedling disease and yield can be impacted for if you're planting green compared to planting brown. And I think that recommendation holds for separating when you terminate your cover crop to when you plant your corn, having that 10 plus days in between the two, based on this research and Giatsna's previous research. However, across the 16 locations, we're still kind of we're getting there to see if this impacts, and maybe it doesn't. We have a lot of factors that are going on across the U.S., different soil types, different weather conditions, and so that puzzle piece might not be moving any closer for those states. Whereas for Iowa, it kind of looks like there is an impact of seedling disease and yield, especially if you're going to plant brown versus green. So future work, what we're going to be looking at is taking all the data we have and trying to put it into some modeling to see what we can find with all the data. There's a lot of data, corn emergence, vigor, stalk rot, barren ears. There's a lot of information that we can be looking at that we took data for. But this, this is just a preliminary look at linear regression comparing root rot severity and cereal rye biomass. And what we find here is that looking for the first 2 years, for all the locations, we have around 12% of the variation in root rot severity is then caused by cereal rye biomass. So again, like I said, might have a webinar in the future that has all 3 years and a lot more information that we can share. So I'll be getting to that in the next 6 months. Okay, so finally, I would to thank again USDA NEPA project of the precision sustainable agriculture. And if you want to, like I said, go to the website. It's a very nice website to learn more about all the different projects that are within this PSA. There's the website there. And also, if you have any questions about seedling disease in Iowa or seedling disease in general, you can either email Allison or myself. And finally, I would just like to thank a couple of people in these pictures. Obviously, Allison, but the next picture to the right, the lady in the blue coat with the hat is Gianna, and the lady next to her is Sarah Kurtz. And both of them, sadly, have moved on from our lab, but they are responsible for the preliminary or the previous research that this experiment was founded on with cereal rye and seedling disease. The next picture to the right is John Shriver. He's our field guy, field specialist, and he's responsible for helping me a lot to conduct these field trials. And also in the next picture over, that's me with our lab manager, Clarice Schmidt, and I'd like to thank her for all the help and support that she provides. And also she's always up for a good time for going and doing anything in the field. So with that, I know there's a couple more slides that I think Anna's going to talk about, but after that, if there are any questions, please let me know. Thanks.
Thank you, Dr. Matthiesen. All right, so a couple housekeeping things here coming up. Up first, if you watched today's webinar and are seeking Certified Crop Advisor Continuing Education units, please send an email today to Elena Whitaker. Her email is on the screen there. It's alenaw@iastate.edu. And please send that today by 5 o'clock with a couple key pieces of information. So your name, the name you entered to watch the webinar, if that's different, and then your Certified Crop Advisor number. And then we'll get that submitted for you. Okay, up next, if you've watched webinars in our series before, you're really familiar with this, but we would encourage you to please scan the code if you haven't done this before for this voluntary USDA demographic survey. So you can find this online at www.iowalearningfarms.org/survey, or you can scan that code on the screen with your smartphone, and that'll take you right to the survey there. So again, if you've done that already for a previous webinar, thank you. You don't need to do that again if you've done it for any webinar in 2023. If you have not yet, we'd kindly ask that you would do so. Okay, and then let's move on to the next slide. I wanted to give a quick preview for next week's webinar before we get into our questions and answer session here. So next week, we will be welcoming Laura Jackson from the Tallgrass Prairie Center at the University of Northern Iowa, diving into her research on prairie. So planning and planting prairie, both research and on-farm experience. So that will sure to be an engaging talk as well. So same time, same place next Wednesday. All right, so that covers, we will leave that up there so you've got that as a reminder, but we do have a number of questions that have rolled in here, so we will get started with those. Okay, let's start out with what planting depth was used?
Okay, so the planting depth for the corn was typically what occurs in each state. So in Iowa, 1.5 to 2 inches. Was what was attempted. Again, when you're going through cover crop that is, planting green, the first year we had a significant amount of cover crop there, and you can get some bounce going on. But yeah, usually it was around 2 inches.
Okay, sounds good. Could you tell us about what the crop rotations were across the 16 sites? So I know it sounded like you had similar management with the corn itself. Were they all in some sort of a rotation, or were there consistencies there, or was that kind of a site-by-site decision?
Right. Sorry about that. I forgot to mention that. So yes, these were all in rotation, and it was no-till, and it was always being planted on soybean. So we got lucky in Iowa, and that was for all the locations. They wanted to, it wasn't corn on corn. So there was no corn on corn, it was soybean and then corn. In Iowa, I got lucky where my field trials were right next to one another. So I didn't have to go very far. But yeah, so it was always planting corn on soybean. What was soybean the year before? No-till.
And that's great. That's actually a perfect tie-in because we have gotten a couple different questions in about the tillage treatment of the plots. So let's dive in. So you mentioned they're all no-till. In terms of the tillage, was the history of the fields tracked? This person wanted to know, there's a hypothesis that soil health practices improve plant vigor. So if the longer soil health practices are incorporated, do you anticipate those results changing, and how that ties in with the tillage management?
I do believe that the field trial site that I was on was no-till for a couple of years previous. I can't say that for all of the locations. However, we can get that information because all of the locations were on research sites, or the majority of them were on research sites through their universities. For impacting vigor, I'm not necessarily familiar so much with the longevity of using no-till on impacting corn. So that would be something I would have to look into. But I do know from other farmers that I have gone to visit that for having longer for no-till, we're not necessarily seeing a difference in whether or not they have seedling disease. I can tell you that much. But versus the vigor, I'm not quite sure on that. But if you want to email me, I can find out, or I can tell you who to to email to find out.
Excellent. Sounds good. So another tillage related question, would a strip till system reduce the seedling disease potential?
So actually, that's another project that I had mentioned, Sarah Kurtz. So she did a project where they looked at that, and we're currently also doing one with Allison, and I believe INRC is funding that, where we are separating the rye from the corn and seeing if there's an impact to seedling disease, which previous research by Sarah has found that there is. It reduces seedling disease if you move the rye away from the corn. But what we're currently doing is looking at, once you are reducing the amount of rye that you have out in the field, is there any ecological services that are going to be reduced? Like, does that increase soil erosion? So we're trying to find the happy medium of moving that rye away from the corn, so we have reduced seedling disease, but keeping rye out there. So we are, reducing soil erosion and improving soil texture and quality. So we're in the process of doing that. So
have you all looked at impacts to earthworms in these systems?
No, we have not. So sorry. No idea. No idea. They might, I could ask in the entomology department if there's any research going on with that for earthworms and increasing earthworms for no-till or those types of systems. Yeah.
Okay, termination question for you. Was glyphosate only used for the termination? And then if so, what was the termination? What was the rate of that glyphosate?
Okay. So yes, in Iowa, and I believe for all locations, it was only glyphosate that was used. I will have to update that with the rate. So maybe when we come out with the article, I can send that to you, Anne, or something. I don't remember the rate right now. It's gone. I kind of knew somebody would ask that, but I totally forgot about it. However, we did not have, I'm trying to remember if we had a couple locations. We tried to stay away from crimping. But I do know that like in Texas, they had the first couple of years, like cereal rye that was above their heads when they went to go plant. And so, it was very tall, very mature cereal rye. So it was difficult to terminate and also to plant into that. So, but I don't believe anybody used a crimper. But I will send an email about what the rate of glyphosate that we used in Iowa was.
Okay, planter setup. Could you talk to us about how that was done, both here on your plots as well as across the other sites? Do you apply any fertilizer with planting? And if so, what fertilizer and rates?
Okay, so for planter setup, I don't know much about that, mainly because that's our field guy. So again, I can get back to you on that to update that. For planting, what we wanted to do was have 50 pounds at side dress, 50 pounds at planting and the rest at side dress around at V4, V5. Again, for the rates of that, it's gone. Or for the nitrogen that we used, I should say, but I know it was, we tried to do 50 pounds of nitrogen at planting and then the rest, which was up to 150 pounds at side dress. So.
Okay, related also with the nitrogen end of things, does starter fertilizer and 2x2x2 nitrogen help with planting green, assuming you're terminating the rye within 48 hours?
Do you mean to help the corn be more vigorous?
If our question asker would like to help clarify there, that would be great. That's my assumption, but I will let them, if they've got further clarification, they can send that my way.
Okay.
So we can go ahead.
Okay, I was just going to say that usually we like that starter fertilizer to help since, with planting green, we're having, the plants are fighting for sunlight, they're fighting for nutrients, or they're fighting for nitrogen. So that's why we like to have that starter fertilizer on there for the corn. And when we don't have that, then we can have lighter colored corn plants or yellowing corn plants. But that's, I would recommend always having a starter fertilizer on if you're going to be planting green for the corn.
Okay, excellent. And that what you answered the question that the asker was looking for. So thank you. That's great. Appreciate the clarity there. Okay, a couple more here. This is great. So this question is, I've heard that if soil's respiration rate is above 100, disease is far less likely, specifically related to rye and corn issues, as the soil is healthy enough to protect the seedlings. Have you run across this guidance, and or what are your thoughts on this?
We haven't looked at that in our lab. That's something that's very interesting. Yeah, I don't really know much about that. That is an interesting question, and I'd have to look into that to see how that would impact what's going on when you would plant green. So yeah, I would have to look into that. That is very interesting, though. Maybe something that we can get funding for and do in the future.
Future research project.
Yes.
Exactly. All right. So I've got just a last plug to everyone. So if you've got any further questions, please get those in now. I've got one more in the queue for Rashelle, but if you've got any further ones, now's the time to get those submitted. So, okay. So Rashelle, could we increase the planting population by 5 to 10% to potentially make up for seedling loss and plant green and maintain yield?
So that was another thing I did not mention. In Iowa, our planting population was around 35,000 per acre. In the other states, we left it up to the states of what they wanted to plant more per what they do in their state. The interesting thing is we going out and taking emergence data, we did see somewhat less emergence for in the planting green treatment. However, it was not significant across all the treatments. So increasing the planting population, I don't necessarily I think it would be if you know that you have a seedling disease issue in your field, it's something that you could try to see if you can balance that out. I just don't know if you will end up with higher yield versus the cost of planting, having a higher planting population. So I don't really see that as a good option. It is something you could try, but I don't really see that as a good option to compensate unless you know that you have a serious seedling disease issue. And then usually what happens with that is you need to go back in and replant those certain areas because you'll have, very low emergence. But yeah, I don't really see that. It's an interesting idea, but I don't think that's necessarily viable to do that.
Okay, and you brought up the importance of fall moisture and temperature for successful establishment of the cereal rye cover crop. Have you seen any correlations or any impacts with the amount of winter snow cover? What impacts does that have, that following, on your both cover crop biomass, Pythium, crop yields? Is that something you've looked at all?
We haven't looked at that yet, but for when we publish the data from this experiment, we're going to be looking at, soil temperature, precipitation. I had been looking at the snow cover in Iowa. So that's something that is on my list. We currently have not looked at it, but that is something that I would like to add for the publication of all this data. So there's going to be multiple publications, but one of them is specifically going to be looking at the impact of weather conditions on seedling disease and cereal rye biomass and those types of things. So be patient, and it'll be out in about less than a year, hopefully. So
it sounds like lots of good information coming in both publications and good information for a future webinar or two. So
yeah.
All right, well, that covers the questions that we've gotten today. Thank you, everyone, for all the excellent questions and discussion here. So last minute reminder, again, I posted it in the chat, but for anyone seeking the continuing education units, please email Alena Whitaker, ALENAW at iastate.edu by 5 p.m. today, and we'll get that submitted for you. And again, we look forward to you joining us next week, if your schedule allows, next Wednesday, December 13th, for Planning and Planting Prairie, Research and On-Farm Experience with Laura Jackson from the University of Northern Iowa. With that, thank you all so much for tuning in today. Have a great rest of your Wednesday.
Thank you.
Rashelle, thanks so much.
Yes, thank
you.
That
was awesome. Yeah, great presentation.
Okay. I was a little thrown off with a couple questions, but that's okay. That's good. Gets you thinking. So, yeah, so I know that usually afterwards there's something written up about the webinar. So
we do a short, like a kind of a short blog recap. Yeah.
Right. So I will get you the rates of the what's the rates of the herbicide was used for Roundup.
Oh, and then that'd be awesome that we could include.
And then I'll also, I just couldn't, yeah. I just couldn't remember what, if we use like urea or UAN or what we use for Roundup, or for nitrogen. Gone. Yeah. I can write it down. So I'll get you that too.
Okay.
So I'll do
that would be wonderful.
Yeah. You want me to email you or Elena?
You can just email me. That's totally fine.
Okay.
Yeah, so ASTAUDT.
Okay.
At iastate.edu.
Okay.
Yeah, that'd be great, and we'll get that included as well. So
okay. Yeah.
Yeah, excellent. And then we'll get the typically we get the recording up usually always by Friday. We may be able to get it up tomorrow as well. So we'll have it up and ready to go for reference. So
okay. Awesome.
Excellent. Well, thank you so much for your time. Appreciate it. And really great talk, sharing your so many results. It's exciting.
Yeah, it's a lot.
You did a great job. I felt like you did a great job distilling it down to what are the really key take-home points we need to know.
Yeah. So, okay. Just let me know if you need anything else.
Okay, will do. Okay. Thanks so much.
Great. Thanks.
Bye.
Bye.